This accident happened in Ikoyi, Lagos, Nigeria. A 2,200 kilogram car hit a stationary 1,000 kilogram car, and both of them started moving. There was energy transfer. So these masses are not the actual mass. I just added them so we can solve this question. But the main idea here is that can Arduino actually solve this? Well, we know we can solve this with our hand, like I've done here. But can we do this in Arduino? Let's first go through this solution here. So the first solution is here that since the second car was stationary, has a kinetic energy of 0. So we got for here I will only kinetic energy of the first car, which is the 2,200 kilogram car that was moving. The other car has zero kinetic energy because it wasn't moving. Now after collision has occurred, both cars started to move. After the big car hit the small car, they started to move because the big car transfers most energy to the other 1,000 kilogram car. So total kinetic energy here now, the addition of the kinetic energy of the two cars after they have collided. Then we got this. Then we get total internal energy, total change in internal energy. We minus the two kinetic energies and we end up with this value. So very simple. But can we do this in Arduino? Let's try that. I already started creating some variables already. So we have the mass of the first car, the mass of the second car, which is 1,000. Then, you know what? Let's do MA for the first car, and MB for the second car. Then for the velocity of the first car, we're looking at the initial velocity of the first car and when they are near collided. Year one. For the first car, it was, let's look at our question. It was, we'll go to the question. It was around, for the first 25 meters per second. I believe 25. Let's put the unit in comments. Meter per second. But this is in kilogram. So, what are the initial velocity now of the second car before the collision happened? Since it was stationary, the velocity will be 0. Now, after collision, what is the new velocity? So what the velocity of the first car after collision, immediate after collision, the light automobile is this 13.89 meters per second. So that is a decimal value. So do float V A2 13.89 meter per second. Oh, sorry. Meter per second. Then float VB2. Or the velocity of the second vehicle 24.44. And that makes sense since it's smaller. It probably move faster when the first car hit it. For meter. Okay, let's comment meter per second. So now we'll do all our calculations in the voice setup. So first thing we'll do is this serial at the beginning. Because I want to print out the value in the serial monitor. So let's first calculate the kinetic energy. Let's create a variable. Int KE. This is the first kinetic energy. Int KE1 equals the formula for kinetic energy is half mv square represented in our equation. We have to do that here, but so for the initial kinetic energy, one of the car was moved, we would have kinetic energy of 0, while the other car have a kinetic energy of a particular value since it was moving. We're also going to represent two of them here. We're not getting just the so the second car that was moved as the 1000 kilogram car, it has a velocity of 0, which is therefore reflecting kinetic energy of 0. So let's do that. But I noticed something with that when I do 1/2 like this, I get 0. Oh, sorry, I forgot to put a colon here. Oh, didn't print it out. Surya.print line KE1 0. But I tested it out while I was preparing the video. I tried to test out the code first. So that 1/2 keeps giving me 0, and I don't know why. But that's not the main goal of this video. But let's if you able to figure out why, can leave in the comment section. So we're going to use the decimal form of it. So go 0.5. The mass of the first car, MA, and initial velocity, which is VA1, because it's half mv squared, so we'll do VA1 twice, plus the kinetic energy of the second car that wasn't moving, which is MB. Its velocity was obviously 0, but it's VB1, as you can see right here. VB1 times VB1. So that's all. So if we run this code, we get this value, which is obviously different from this value. Why? So when solving maths while programming or in Arduino, it's best to use float, because you don't know how the numbers are going to change throughout the whole solving process. For example, now I use float values here, and I'm using them to get out integer values. That's not really a good idea, because now they're all going to be available as an integer. So during the whole process of solving, it's probably going to cut out this part of the equation, cut out all the decimal part, because the variable is entering as an integer value. So if during calculation it gets the decimal value, it's going to cut that out. So imagine how many times that would have happened during the process of solving this question. It's going to cut out every decimal part that comes out. So we're going to deviate so much. You can see how much if I deviated. This is 687,500 joules, and we have 32,767 joules here. So deviation is high. The best is leave all your values in float. We have changed all our integers here to float. If you don't understand what I just said, click on the banner, little banner at the top of the screen. It gives a video where I explained about data types in Arduino to help you understand what I just said earlier. So let's continue. So we change this to float. So just copy this. So this stuff I do in VS Code, let's see if it's possible here. Oh, it works here too. So you can now, if you hold down Alt and click, you have multiple cursors. So I can just look. Yep. So we have that now. So when we refresh this, so now we get the correct value. See? So now let's move on. So now let's get the kinetic energy after collision. Float KE2 equal to, so let's just copy, this one at the top and change the values. So MA is going to be VA2, and the velocities are the one that are changing, VB2. Now let's print out KE2. Okay, so to run this 510.88.2, let's see what we had here. 510, approximately the same values, so I'll stay good. So the next thing to do, just to minus the final answer is just to minus the two of them, K1 minus KE2. So you get the final answer, which is around 176,000, which is similar to what we have here. So the values are not exactly the same, but of Arduino Solve, I solve it in more decimal places compared to what was solved here. So the displacement approximate values were so we don't have the exact same values, but they're pretty close. So I think Arduino is more correct. And before I move on, this question was not created by me. The question was not created by me. Actually, my lecturer will just give us this question in class. I don't shoot this for this video. So let's try to solve something else. This, okay. Water discharge from a large tank. Let's look at the question. So a large tank opens the atmosphere filled with water of 5 meters from an outlet tap. A tap near the bottom of the tank is open and water flows out from the small channel outlet. Determine the amount of water velocity at the outlet. The flow is incompressible, rotational, blah blah blah. Assuming Torres equation as given in figure 2, which is this here. Torres equation is basically root 2gz square root 2gz. So we have g is constant 9.8 and now z is the height, which here which is 5 meters. So what we always have to do is to do root 2gz. So let's clear all this up. Let's create some variables. Float g equals to 9.8. 9.8 is a meter per second squared. Now our float on z is equals to 5 meters. So you have to come here and you'll do float, let's say the v, which is the velocity of the water coming out of the tank, of the square root 2 times g times z. That's how easy this is. So run a value and we get, oh, what's it? Okay, then put a colon here and here and also here. To run this and got a value of 9.90. Boom. But the whole idea of this video is not to just show you how to solve some engineering based question. It's to show you that as far as you know how to solve the question, you can solve it with Arduino. So if you know how to do the question, you can basically do it with Arduino. It might just be maybe way too long to do it yourself. So it might faster doing it with Arduino, but as far as you know how to do it, you can also do it in Arduino. So that's for like the other math functions you can use it, like the sine, cos, tan, arctan, and other stuff. But I want to keep these which are very basic. You can always read them up online. I cannot search Arduino sine, Arduino cos. Just add start whatever you're searching for with Arduino and put the other stuff you're looking for beside it, and Arduino will be the first thing you see in your Google search. So thank you guys for watching this video. I hope I see you in my next video. And please, if you like this video, please like it. If you like the video, a lot of people are going to see the video when you like the video. And if you also love the video, please subscribe. Thank you, and see you in my next video. Bye.